Hello and welcome to another weekly live stream where I just keep pushing the ball down the field, so to speak, on Mythruna development. Tonight we're going to be working on goal-oriented action planning and integrating that for real. Well, we're going to start with integrating into the prototype and developing some sort of debug tools. GOAP, as it's called, GOAP, it can be difficult to debug. So anyway, without further ado, let's go ahead and kick into it. Those are my patrons scrolling on the left. The folks that still believe in me and have stuck around through all this time. I really appreciate it. I occasionally get discouraging comments on YouTube about my age and the length that the project has gone on and so on and so forth. So those who still hang around and believe in the project, I appreciate it. And recognize also that a good deal of the foundational software is open source anyway. So even if I were to kick the bucket or whatever, there's a lot of this code that we're writing that's still out there. Anyway, tonight, so I've been messing around with the goal-oriented action planning again in the last couple days because I was trying to solve a few issues with how the rules are constructed and being able to sort of parameterize some of that stuff. I don't know if you remember before we had this these rules set up with where we were trying to get an NPC to create a dagger and get it from different places and do the steps needed, and we had all that working a couple live streams ago. But it was all very hard coded. These weren't real objects; they were just the string anvil and stuff like that. And in the real world, this would have to be some kind of entity or object ID, and then these rules change a little bit. So I was trying to build one of the simpler animal behaviors that we've got that's pretty close to the final version. The behavior that I expect from the Gafen, for example, in the current game is pretty much spot on with what they'll be in the final game. It's just implemented in a different way. So I was trying to sort of build some of those rules out, and in fact, I can get rid of this. And so, I parameterized things a little bit more, where instead of hard coding it, these were based on objects, and instead of just giving it as part of the world, state, instead of just giving it the actual object, I would make a world, where there were objects nearby, and then it had to pick which one it was going to use and stuff like that. And so I made this really simple, he's hungry, he wants to eat food, so he's going to have to find the food before he walks to the food. And I was able to get that to work. It didn't at first. And during that process, I optimized some other things. But to remind you, when running that stuff, see, that's over here. This one? Yes. So it reminds you, when running that stuff, it's it dumps a lot of stuff. I currently have it set to dump a whole bunch of debug material. So hold on. And so I can sift through this, and this is a really simple plan. So I can sift through this and I can kind of see what's going on. But in a game, this is not acceptable. If you have 15 NPCs walking around and trying to debug what they're going to do and so on and so forth, it's not really conducive to that, digging through logs to look through, this is just one plan that it planned out to find a piece of food to eat. And then before, what we were playing with was we had that rigger tool where, the last I left it, I was working on, the generic mob motion controls and things, and I think that's basically we'll come in here. What I plan to do tonight is come in here, start adding a behavior to the Gafen, because they're going to have the easiest behavior. We might actually be able to fully code their behavior in here tonight. So to give this Gafen some behavior, we'll add a little drop down here, maybe to select a I don't know if we'll add a drop down, but we'll add some buttons or something to select a goal for it. Initially, just so that we can manually trigger goals. If it was a real NPC, this is the kind of thing the town would do, but I think things like Gafen may be like more unmanaged. I don't know. I guess they'll still have to, if they flock or something, they'll still have to flock with their owner and stuff. They'll have a daily schedule. Anyway, so we'll start building out, the GOAP rules. I'll start like turning these simple GOAP rules over here. And I can always debug them over here in the unit tests, but it would be better if when I have this guy selected, if I could click a button and get a little pop-up and let him step, basically when I click the button to set a goal and get that started, that I could have him step through his planning, with some output at each stage. And ideally, it would be nice if I could even bring up the rule sets. Like I had this with the complicated planning test, I had it take this rule set and dump it as a dot file, which is a graph file, and I loaded it into this tool, which I'm not real happy with. It doesn't have, I just get Gephi. I've just downloaded it today, and I don't know how to get it to show which direction the edges point, and so this becomes a little weird, but this is basically telling me how all those rules relate together, how go to forge changes the location, and you need a particular location in order to get the dagger. It doesn't know which location. It's just showing you because the actual execution of rules is based on the state. Oh, so this is another thing I wanted to talk about. Like currently I spent a lot of time doing what's called backward chaining. And so if we were to look at how it figured this out, it started at the goal where it wanted to reduce its hunger. That's its goal. Yeah, so once you get a hunger, yeah. So it's going to find rules that can affect hunger. So it's working backwards from the initial state. If you want to think of it in this picture, it starts, this is not the right picture. Anyway, and maybe we'll make a generic dot writer so that I can load rules into, because this was specific to this particular unit test. But so it looks for all of the rules that might affect hunger, and the only one it finds is eat food, because it's the only one, there's only 3 rules here. And so then from eat food, it looks at that, and it's like, so it's working backwards. Well, so how would I eat food? What would I need to be able to do to eat food? And it finds that, and it finds, oh, well, in order to eat food, I have to walk to food. And then in order to walk to food, I have to find some food to eat, which will set the location, and then I will know where to walk, and then I can generate a plan. And the plan is, look around to find the food, walk to the food, eat the food. So we worked backwards from where we want it to be. And the idea being that if you had, hundreds and hundreds of rules, that it would tend to be more efficient to work backwards, because you've got this whole rule set where 90% of the rules have nothing to do with the particular action you're trying to do. It creates a whole bunch of mental gymnastics, though, to try to look for duplicate state, because you're exploring paths that you haven't actually decided you're going to take yet, so you don't really know what your state is, and so on and so forth, versus a normal pathfinding algorithm, which would totally work as well, where you start from where you are now, and you see what all of the actions you possibly could perform right now are, and then explore their state, kind of like when you're doing, A star, kind of like when you're, kind of like when we're doing the nav stuff around the map. You start from where you are, and you explore all paths until you get to your destination. And the problem with the rule set is, you're exploring a whole bunch of rules before you find the one you want, and it's not so trivial to decide what a heuristic should be to get you there quicker. A star basically says we don't want to explore everything, we want to explore the paths that are most likely, and so it uses a lot of times a distance function or something to say, as I get closer, prefer those paths, so that it's less likely to explore all the ones behind you. But it will, if it has to, if this is all blocked and so on and so forth. But so action planning could be done in a certain way, in a similar way with the forward chaining. And so then I get into just, so general graph APIs and things. Whereas backward chaining is really tough. And actually, when you're doing general pathfinding, where you're searching the whole space, working backwards and forwards at the same time, like if you're your GPS when it's working to try to find you your directions. It's probably working backwards and forwards at the same time, because each time you branch out, you're exponentially increasing the number of paths you're checking, and so it reduces a lot of that by starting at the end as well as the beginning, and then wherever any of these paths meet, pick the shortest one, kind of thing. And so I'm also wondering if there's a way I can exploit that with the GOAP rules. Continue to do backward chaining, but at the same time, just do general forward chaining. Especially if I could think of a way to come up with like an A-star heuristic, like if basically prefer to do rule paths that are actually adjusting the state variables that affect your end goal. So if he's hungry, some of the actions he has available are related to sleep or going and hanging out with his friends or whatever, but he's going to tend to want to do the actions that change the state to getting closer to the things that would match his end goal, which is to eat food. So anyway, there's the things I'm playing with, and it would be extremely useful if there was sort of a more interactive tool. Well, certainly more useful for live streams. I mean, this is kind of a pain. It's really a pain to try to explain what's going on a live stream. And I could probably tailor this debug output to make it a little clearer, but I suspect that this text is too small for you guys to read anyway, without blowing it up on a big monitor. So anyway, visual would be good. But I mean, one of my goals today is to at least get the basic AI set up in this tool so that I could give him GOAP behaviors. I spent a lot of time doing design work this week. Okay, so he's running. We want to sort of relearn how he works. And yeah, I set it up so I can turn off some of the query shapes. I may find the axes as well and turn those off. I don't think we really need to see his little arrows. Let me see if I can find there's a so yeah, we probably don't want to show raw context. So just tweak the debugging a little bit so that we remove some things that should redo it. We'll still see his arrows because I'm not sure what's doing that right now. But this is the kind of thing I was trying to do this before the live stream started, but I got stuck on something else. This is the one. There's the basis vectors. Show basis vectors. Boolean equals false. All right. There we go. Now he's a little cleaner. So now we can give you some behaviors, and we're gonna have to figure out what eating food and finding food means. I may have to have a way to scatter some food around. But anyway, or we'll have the function that finds food pick a random, or just create some random food or something. All right, so we've got that. Trying to remember, he sets up a. There's something that sets up the drivers, probably at the bottom. Oh yeah, we added the jump. I think for now, well, okay, I'm gonna leave that because this is not what I was originally testing, and I do want to get back to that. So, so this is the driver delegate. So this is what we used to set up the. And then driver delegate is the one that we can set specific scripty things to. Yeah. New speed, new contact update. Yeah. Okay. So update body. And in here, where we have been actually, for now, because we've set this up to be controlled separately, let me see, I think I can add another system or something on top of this. We control here. I set a movement target, which then sets the movement input. And movement input is context calculate steering. It's part of the body context. So we can actually just give it its own calculate steering. We've already got the plugs in order to set the AI up. And so let's just test that. I hope everything in the stream is working. Let me check one thing actually. I like the Gafin's idle animation. He's one of my favorite characters that I've ever made, by the way. I like the dog too, but like the Gafin's a 100% original character. And his idle animation, I just get a lot of life. Okay. So I think if true, if have manual control. All right. Oh, we'll put that over jump too. Yeah. Okay, so then we'll indent all these guys. I forgot to pop up my little dashboardy thing. I probably didn't need to indent these. It's just a waste of time. Alright, and then so if I do this, it will remove our ability to manually control. Oh, it did not though. Oh, we had a error. I set it to false, right? It should have removed my ability to do this. Ah, yes, it did. Yeah. When you remove, it doesn't remove them automatically. It won't add them, but it won't remove the old ones. So if we go back over here, start simulation, and create. Oh, we don't want to create the bird. Cancel. Cancel. We want to create this bird. Center camera. Yeah, so now we've got just center camera and delete, which gives us a little more room to play with if we want to do some different things. Because I don't think we can add like drop downs and things to this. So I'm going to want to have a little pop-up or something that we can click on. But now we have the ability to set our own. So let's add another boolean. Use GOAP. And then down here, if use GOAP, we're going to set up our first. I just want to see if this is going to work. I think if I just do one 0, 1, he's going to walk around in a circle. Whoops. No, well, I got to get, I made a compile error somewhere. No such property oh yeah, of course. I didn't do this bit first. I'm going to indent this anyway. It doesn't need to be, but why aren't you? No such property driver. Okay. Oh, because these. Yeah. Okay. We have to have it like it has to be triggered, or it won't have access to the things it needs. I thought I could just say, oh yeah, okay, we've got lots of issues now. All right. Okay, so now we should be able to say start AI. Yeah, so he's like just zooming around in a in a circle. We slow him down a little bit, and then we start the AI. Start AI. Yeah, so then we could slow his rotation down too. So the point is, we can add our own behaviors to calculate steering and have that be our. Yeah, so he's apparently we still show collisions. Anyway, so if we just hit this reset, and it'll stop him again. All right. So we got the beginnings of what we want to do. And so we can plug whatever behavior in here that we want when we start the AI. And so then we can define what we want that AI to do up here. And yeah. And so what is that we want to do? Let's, first of all, let's import the open source GOAP stuff I've started. SimSilica, GOAP. Yeah, so see, all of the GOAP library is part of the open source MOS stuff. So hopefully other games might use that at some point. And let's create our rules. And when we do this, it might be worthwhile to start thinking about how we want to structure this to make it easy to write in Groovy. So let's actually make a class GOAP agent driver that we can give some stuff to, and then we'll just have an update method on here, and this will take our movement input. So hold on, I want to capture this for a second just to have because that's the way I like to code here on the live streams. Have my reference code there for a second. Okay, so the GOAP agent driver is going to want some things. It's going to want the body context, probably. Does the body context contain the driver, or is it redundant? Oh boy, lots of stuff up here. Body context does not contain the driver, so we'll want that driver separate, because probably we will want the driver. And driver is, we'll just call it object driver for now. Body context. context, and we'll go ahead and set context. We'll add like a context variable to def AI. So we keep track of ourselves, and equals this. And we'll just say context calculate steering equals update. Oh wait, it takes that's not going to work. So we'll have here, we'll have vec3d steering move input, I'm going to call it. So here we'll say move input, and here we'll have update. And so in here we'll say move input set 0.1, 0.1, so we get like a really slow turn to prove that we've done something. And so with this, instead of doing this, we want to say context AI equals new GOAP agent driver context, and we do this. Then when we start the AI, he should start moving around in a little slow circle. Yeah, walking in a little slow circle. Oh yeah, I've still got the jump behavior in there. Ha, that's funny. I need to turn that off though. Oh, it's funny. He's turning really slow. So eventually he'll come out of that. But let's look for jump. I think that I want to turn off that jump behavior. Jump action is the one. Jump up action. Where do we set that? Where do we do that? Jump up action. If what is this showing? This is showing targets, but also somewhere up here is setting whether we jump or not at all. If jump supported, and okay, so let's add this. Alright, so that should eliminate him trying to do that jump up thing. Yeah, he'll just walk around. Yeah. Cute little guy doing his little walkie walk thing. Alright, so the AI is hooked up. It's not doing anything, obviously, but it is hooked up. Okay. Let me pull up my little stream stats. I guess we have a couple people on. Welcome. Hope you all had a good week. I had like a really busy week. We did like a brief planning because we were only like planning for half the quarter at day job, but I was still trying to get like 4 hours of Mythruna work in a day. It was a little tricky. Okay, so then up here we want to be able to set up our actions. So right in here we want a rule set And let's say configure Gaphen rules and rule set. So then we can come up here and we can make a little configure Gaphen rules, or configure Gaphen and takes the rule set. Action rule set rules. Yes, that is correct. All right. So we're going to need like a ton of classes and stuff to support this because of the way the condition keys work. They're their own objects because they can look up their values. I'm not 100% on board with that idea, but it's super convenient at the moment. And so in here, yeah, we configure the Gaphen, and so then now we can add our rules. And I think what are you doing? Why are you you're blocked false? I think maybe we want to get rid of that debug log rig move. Yeah. Let's take you out for now. If false, and there we go. Oh, I've got compilers down here, I'm sure. Crap. New action rule set. Unable to resolve class. Oh, I bet that these tools don't refer to that yet. Okay, so I got to change the dependencies. Yeah. So tool runtime has to depend on GOAP. Alright, let's try again. Uh-oh. Oh, I don't... Yeah, Gradle install. Uh-oh, we lost a viewer. I recognize that on a 9 o'clock my time on a Saturday night is not the best time to do a live stream. I hope to get back to earlier times, maybe do it on Fridays again here soon. Oops, we don't want her. We want, although it would be fun to watch her walk around with Gaphen animations. Okay, center the camera. And then if we start the AI, she should start walking in a circle again. Oops, uh-oh. At least it's not streaming down. No signature method goes configure Gaphen. For argument, action rule set. Maybe I've got that spelled wrong. Let's go over here. Configure Gaphen. Oh, it's because we're in a class. That's fine. So let's do this different. And so we'll say this dot rule set equals rule set, and when we create it, we'll just pass that in. That should work. Start the AI. Boink. Yeah, okay. Now he's walking in a little circle. Okay. Let's put him over here so we can watch him walk in a circle. Alright, so we're starting to get things set up. And I think I kind of feel like if we added, if this returned the rule we were adding, we could do a little bit cleaner configuration. So I'm going to have to kill the tool again, unfortunately. Do this. Just trying to get rid of some of the redundant code. Alright, start the simulation. Boink. Okay, so we can center him. Alright, he's doing his thing. Just wandering in a circle, minding his own business. And then we can come back over here. Excuse me. Alright. So now what I should be able to do is say, I should be able to do something like with rules.add new action rule eat food, and probably don't even need the let's see if it likes that or not. No, it does not like that. Oh, I've got a mismatched. Oh yeah. This. There we go. Yeah, it likes that okay. And so then in here, instead of having to call rule dot, we can say requires like this, and then add the things it requires. And so we're going to want to make our condition classes and things that those will be standard across a lot of things. So near, let me steal some of these classes from the AI tests. Yeah, we don't need a game object. Although, so just put them over here for now. Okay, so near implements that. Put this over here. And so, yes, get ID. Get world value is where we get interesting. I think that's okay. World is going to be a our own object of our own choosing, really. So it's whatever we define near to be, and world is whatever object we want it to be. So for now we'll leave it like this. So in the, GOAP is keeping track of, as it's planning out which paths to take, it's keeping track of the state of the world. But it, like, when it asks for something like, who am I near? What am I near right now? The first time, and normally this would be like a list of things, right? Oh, it doesn't want to be game object, that's for sure. I think we have real entities. Do I have an entity system available? Ooh. I must, because that's how we're doing debugging and stuff, I think. At any rate, but then in order to get its initial value into the world state, it asks the world the first time, and then from that point on, whatever the rules are doing to modify it get tracked so as it goes through the different rule paths. But so that initial set is like querying the world, whatever the world is in this case. And it doesn't have a game object. Let's do entity ID. I think this works. Hey, it compiled. Alright. So, we got that going for us. I think ultimately I'm going to set up a base class for this because like all of these end up being about the same. Oops. Alright, so we should be able to set up our first rule, which is requires new condition. Actually, we can just do this one line. New condition, new near, whatever we're near. It has to be the type of food. Type equals food, and we'll have to set some entity system helpers up to make that work. But that's all doable. Groovy's groovy in that respect. Alright, and then we can set up what it does. And that's the tricky one, because we don't know what it is. That's the part I haven't really defined yet. And I don't really want to have, so we're going to have a self. So that's what it requires. This is what it does. Actually, we can just say does. For now, we'll just let it, we won't make it do anything. We'll just say this is the context. I think that works. Okay. So that's what it does, and then what it changes. So if it changes, it's going to be at one of these. New action result. New hunger, which is something we haven't defined yet. It -1. So what this is saying is there's going to be another one of these hunger not junger, but hunger classes, and it returns, I think, a double integer. And so this is getting my own hunger. 1, 2, 3, 4, 1, 2, 3, 4. Because the world that's being passed here is specific to this particular entity that the rules are running on, so it can get things that are specific to itself. So it's not really a world in that, it's like a world from perspective of a particular entity. Okay, so that should be okay. So basically we're saying whatever from a rule planning perspective, we're trying to tell it what will happen. This is actually what's going to happen when the plan is created. This will be setting, the actions on the entity and, modifying the entity ID and so on and so forth. Yeah, so maybe we flip these around, because these first two are what's used by the planner, and this is when we actually execute a plan. what do we do at this step? So this would be modifying the actual entity. Whereas all this stuff up here is theoretical. It's just messing with the state, the planning state, as it searches for different options. So this should be fine. Yep, okay, so then if it had food nearby, it could eat the food, and we could plan that. We could actually test this in a way. We could add another, like, how did I start the one in the test? It's like got, yeah, so we did this and then we planned. So let's do this. Boy, try to eat. And we'll set it up and we'll run the plan. And why isn't he walking in circles anymore? Oh, I didn't start it, that's why. So we don't want to do this anymore. Okay, so start AI, eat. And in this case, we will grab the body. So in this case, we'll call try to eat. Try to eat. And we need what we think of as the world. Map world equals new. I think body, one of these body context or driver or something has an entity ID, I think. It honestly doesn't really matter. We actually could just we could get by on just putting the context in there. World put context, I think. Or we could put driver this, just to give us access to ourselves. And so this will just set some stuff up. Our hunger, just random, makes us hungry for sure. We could then preset a specific thing that we're near. So it's like put new near new entity ID 42, just to see if we get there. And planning world, context planning, new hunger. Yep, so we want our hunger to be less than 5, so it's just going to do something until it's less than 5. And then we could say planner iterate a couple times. Planner iterate 10. I think this is actually going to blow up, because we don't have any ID doesn't have a type defined. I don't have any of my cool stuff. So we'll start the AI. Yep, so we're already failing. No signature of method. Action rule set add is applicable for action rule. Okay, so with is not going to work like that. I think I have to put the extra parentheses around. Let's see. Nope. What am I doing wrong with the with? Oh, I know what I'm doing wrong. It's dot with. I think. Must be. Okay. Now if I click eat, it's going to blow up because it's going to have, yeah, there's no such thing as some of the methods I'm calling. Oh, okay. Well, it's failing in a different place than I thought it was going to. Step. It's probably step, isn't it? Let's see. Planner is one of the first ones open. Step. Yeah, okay. Blah, 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 blah. Thanks, Past Paul, for being consistent. Step 10. Step 10 times. Boink. Alright, so we want to start the AI, so we have the AI. Then we want to eat, and it'll blow up for a different reason, hopefully this time. Error running eat. Yep, no such property type for, yeah, okay, this is exactly what I hoped would happen. Okay, so, do we even have an entity data? I just don't remember. We must. We must. Where's my shape debug? Shape helpers, shape entity, entity data. We have systems and entity data. Yeah, okay. Okay, so we definitely have that stuff. Am I using it anywhere in here? Yes, I am. Alright, so all over the place I use it in here. So up at the top, I'm going to do this. Just so we have it. And then I'm going to steal some code from Mythruna that adds special things to, like in Groovy you can extend objects that aren't even Groovy objects. It's kind of cool. Using the meta class stuff. Where is it? This stuff. Yes. So you can add like your own things to it. This is how the action stuff works. I don't want all that stuff, but I do want the type. Okay. We'll probably add position and stuff here soon as well. But in the meantime, up here, let's configure some things we want. We want yeah, this is convenient. This is a string. Get name. We want this one because that's super convenient for not having to have the entity data. Let's go back down here. Let's put this down where we're going to use it. So then rather than call system in each one of these, that's why I grabbed it first. We want that. We probably want is same entity. We probably want left shift to add components. We probably want remove. Contains is for container stuff, which we're not dealing with yet. And then we definitely want type, which is this one. Object types get type delegate. What are object types? Yeah, we don't have an object type registry. So I will cheat and just use the object type info, because we just want the type name. In fact, I'll change it to type name. And we want entity system. I just got sidetracked for a second. Object type info. Get type name. Okay. Alright, type name. Excuse me. Entity data, get component, delegate, object type info dot class. Oh. Hey, Ron Morgan. How's it going? Long time no see, man. Get type name, entity data. I think this will work, and then we can come back down here and change this to type name. Let's see what blows up this time. Start the AI. Oh, it didn't blow up. Eat. Okay, blew up, but what did it blow up? It blew up. No object info. Aha! That's easy to fix. Let's try again. Start AI and eat. Okay, let's. Why did we blow up this time? No such property entity. Entity. Typo. So somewhere I've misspelled entity. And it told me what line, but I don't remember. Right here. Okay. Let's try again. Start AI and eat. Alright. Alright, look at that. Condition ID. So, effective proposal. We don't know if the plan was successful. We never checked to see if the plan was successful. If then log system. Oh, just print line here. Print line success. Bobaverse book 4. Bobaverse, huh? I'm not sure if I've ever heard that one. Alright, so then we can get the plan and dump it to the screen. I got lost in my own code here. It is the planner. Get the plan, alright. Plan each print line it. Wink. Okay, let's start again. Start AI. Eat. Okay, it was not. Oh, we did get success, but we don't have a plan. Okay, so we failed basically because we couldn't find checking eat food ID doesn't match. Eat food should have had hunger. Okay, something's gone wrong in our rule definition. It didn't even try. Well, it's looking at eat food, and it can't find. Okay, we don't have any rule that produces near, but we already are near. So that means this particular rule that we're executing, this is not actually coming up with anything. So let's print line. Let's try again. Start AI. Eat. Okay, type name is null. Oh, we never. Yeah. Okay. Yes. There is. We did in fact create a. We didn't actually create the entity. So. Right, we just randomly pulled an entity ID out of thin air. We could still do that. It's not really right. Because entity ID 42 was probably used for something else already. In fact, we can make it minus 42, and I think that's allowed. And then we can say food, new object type, or object type info. This is where we're going to screw up. And I'm going to steal some more Mythruna code. The problem is in here we don't have an entity data. Maybe we just give ourselves one because that'll just make life easier. Alright, so then this.ed equals ed, and now we have all kinds of, so we can say ed create entity, and then we can say object type info create food ed, and then where we're creating this, we just need to pass our entity data. We do have an entity data here. Alright, so that shouldn't blow up. And then if we yeah, so we should be able to try the AI this time. Eat. Boink. Okay, we blew up for a different reason. That's good. Get context value is applicable for near. Alright, so that's on 1236. Aha. Planning context, get context value. Planning context, get context value, or it's just get value. That's why. Did I copy that wrong? I did, in fact, copy it wrong. Alright, let's try again. Oh, we got 4 people on now. Alright. Cooking with fire. Alright, look at that. It came up with a plan. It eats the thing. Alright. So now we can start messing around. Actually, I believe that I believe we have a whole entity system, and that's how it's doing the models and things like that. And so I think we can create some real food entities and really flesh this out. Let's make a food object. I may let's just make a, oh boy, I forgot that blocked is currently configured to ginormous size here. Alright, let's do this. Should be default size again. Oh, we got to 5 now. Cool. Yeah, so this output that comes up over here is something that I'd like to create sort of UI-based things for. But anyway, let's let me just make sure I don't have a little food block already. I don't think Apple works anymore. Yeah, it doesn't. But on the other hand, it may work better than anything else I've got. Oh, pumpkins. Sure. Okay, pumpkin nut blocks. We'll just use a pumpkin. Little teeny pumpkins. There's source main, resources, models, objects. Do I already have a pumpkin? I don't. Interesting. What about in items? I do, pumpkin.blocks. So models, items, pumpkin.blocks. Alright. So back to here. I do believe run rigor. Let's go back over here and real quickly let me copy this. Oh boy, that's not good. Alright, what are we blowing up on when we start up? No such property systems for class system helpers. No, that's not right. Maybe it's not set up yet when we run. That's what it is. Problematic. This is probably why I didn't have this out here like this. So we're going to do this weird thing. I hate this. Actually, we won't. We're just going to replace everything in here with system entity data. Just get rid of this global. I get so used to the things I have set up in Mythruna already. And so let's, where else did we use entity data? We're going to just say system entity data there too. Alright, let's try this. Because when we're running, we reload the scripts. They have state left over from previous scripts. So the first time we ran, you know, it filled in the systems closure. And then and so then subsequent times already had that, even if it wouldn't normally have been ready when they first started up. Okay, so let's just make sure everything still works. Start AI, eat. We still get a plan. Cool, cool, cool. All right. Center the camera on the Gavin. I mean, he's not going to do anything, but I like to watch him anyway. I don't know if we'll get to the point of actually making him walk through these actions, but I want to get to. I would like to get to the point where at least his rules are implemented, and we could maybe start thinking about what kind of debug tools we want other than this log file. I'm pretty confident I can make him walk through the actions and so on and so forth, it's all about the planning. And so there is a way, set up objects, there's a way to add, we should be able to do block models already, and shape info. I just need the right imports. I believe I don't have this one yet. And so we will and spawn position. Shape info and spawn position. What I'm trying to do is see if I can create the actual food entity. So food, we're going to make it ginormous for now so we can see it. Well, not ginormous, but not teeny, not like something that the Gaphin could actually eat. And we got to give it a position, which, oh boy. I think we're going to create another helper method. So many things to do. Da 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 da. Oh, that's even better. Okay, so up here, that should be okay. And so then in here we should be able to create one of these new spawn position, new vec3d. How can I get my position? Because we would ideally like to scatter some. I have physics and everything here. I forgot about that. We can not only, yeah, it's not like the town where I don't even have physics. But let's just make this 10, 10, 10. New quad D. We'll make a static object at first. Let's see if it blows up. Not yet. So then we'll start the AI, and then we'll eat, and now it blows up. No such property, game constants. Okay. That's an easy one to solve. Okay, try again. Start the AI and then eat. Alright, we good. And so somewhere it created a pumpkin floating in space somewhere. Maybe way too big. We'll see. Oh, maybe it didn't. Could be something I'm forgetting. Oh, I didn't. I think everything has to have a mass, maybe. I don't think I can create holograms anymore in this engine. Let me see what the door's doing. Okay, so it had to create a named entity. It created the shape, the spawn position, and it did give it mass. So let's give it some mass. We'll give it a little bit of real mass so that it'll fall, maybe. Okay, first we'll make a static object. Boink. Alright, so start the AI and then eat. Whoa, okay. Bad things are happening. Resource not found. Models, items, pumpkin.blocks. Dir block set source main resources. Models.items.pumpkin.blocks. Alright. Are we pulling our resources from somewhere else? Source main resources. Where? Where am I getting this? The wood door assembly. Oh, blocks models. Okay, so we have to put specifically in blocks models. Dir source blocks models /s. Okay. So copy block set source main resources object models items pumpkin blocks to source main rigger blocks models. Yeah, we'll just stick it there. And under source main rigger blocks models objects. Move pumpkin.blocks to objects. Oops, one too many. Okay. So now if we change this to objects. Pumpkin. Actually I wonder if it would have worked if I had put the slash, to be honest. It does need a slash, I think. Nope, apparently not. Okay. Anyway, let's try again. About to run out of Pepsi. I maybe have one more sip left. Come out. All right. Start the simulation. Come on, Gafen. Boink. Start AI, eat. Okay. Static model added. So we do have a static model somewhere. Yep, there it is. Nice. Okay, so we should be able to get our own location too. In fact, I'm going to add some of the other helper methods. Entity ID meta. So one of these over here was the location. Yeah, get location, get orientation. So let's just steal these and copy them over here. So if we add these to the meta class, then oh yeah, that's perfect. It'll even use the body position. Probably then we want to import bpos.start. So what this allows me to do is put a piece of food right above. I should probably also clean up entities. Yeah, so clean up entities, add food. Oh, clean up entities is not available here. Do I support decay? Oh boy. Yeah, so we're just going to keep building up food every time we run this. Unless we move this somewhere else. So let's Alright, we'll keep it here for the moment. So instead of this, let's do... I don't know what my entity ID is. Well, it'll be in the body. Driver body ID or something like that. So let's say driver.body. Oh, well, that would give me a location anyway. Never mind. 0, 10, 0. So this should put it right above our head. So we say start AI eat. Nope. No such property location for class rigid body. It's position. Bet you anything it is position. Because I'm really inconsistent with that. Ah! Yep. Okay, so we got one placed right above our heads. And if we gave it a little mass and we made it tiny, then it would even fall on our heads. Let's actually make it start not so far above our heads. Okay, so if we start the AI and we eat, boink, yay, we got a little one that little pumpkin that he can go eat. And so now every time we eat, it's going to drop a new one. Yeah, so now he's got a bunch of them to choose from if we implement the rules such to do so. They're like never going to sleep for some reason. Anyway. Alright, so we have food entities in our thing. And I think what I'm going to do is just, I'm going to have it only run this if there aren't already entities present. So we're going to ed find entities. Uh-oh, my chair is sinking down. Old chairs do that sometimes. It's really annoying. Okay, what do we want to do? We want to find entities where object type info I don't think I metaclassed the filter. I did though. Where's the other object type info I did? I didn't. I didn't. That's nice. Okay, so type filter, and then we've got a entity data. Yeah, so we've got to steal this. Okay, so just kind of wiring it into the entity system. Entity. And so in here, we want to say, first of all, I'm going to stop doing this. It's going to fail. Anyway, object type info filter food. Oops, object type info. Object type info dot class. Man, I cannot type today. Each print line it just to see if it's working. And so we'll start and we'll eat. Okay, nope. It blowed up, sir. Object type info filter is applicable for type string. Except for we did create that up here. Type filter. I'm a big dummy. Alright, let's try again. Boink. Start the AI. Eat. Alright. Did we find any food? Did we find existing food? where would we have seen? Yes, it, blah, 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 blah. In fact, we can go ahead and remove them right now. Ed remove, I think just like this. Is it remove entity or remove? I can never remember. Start eat. It must be remove entity. I bet you that's what it failed on. Yep. Okay. Boink. Alright, let's try again. Start AI, eat. Okay, so it removed all those. We should no longer have, yeah, so we don't have any pumpkins here. And so now we can create a bunch of new ones if we wanted to. Yeah. So def existing equals excuse me. If we just want to clean up, we'll do this. Otherwise, if existing is empty, int count equals 3 for int I equals 0, I is less than count, I plus plus. We're gonna, so for each one of these, we're gonna make a new little food guy. Oops, new little food guy. Random rand equals new random. And def pass equals twink twink twink. And then we will pass.add driver pass.add 0 ran.next double minus 0.5. Make it above our heads, and then rand.next double minus 0.5. So we're going to add, well, we better pass equals pass.add. Alright, so now it'll create 3 random ones above our head, and eat. Boink. Yeah, so now we've got some food around us. Which should be good. By the way, if anybody remembers when I was dealing with the Gaussian randoms before and I was trying to normalize them to 0 to 1, my math was completely wrong on that. Not because of the 0.5 thing, but because random Gaussian can actually be plus or minus infinity. It's just the standard distribution is like the standard deviation is plus or minus 1, but you can have values outside of that. Like 70% of your values will be less than 1 or within that. But anyway, so to normalize that was a little more complicated than what I did. So I ended up clamping it, but it's neither here nor there. Okay, so it shouldn't do it again. If we were to hit eat again, it shouldn't make new ones. Okay, cool. All right, and it should have failed. Oh, it's success. Yeah, okay, but it didn't really succeed. It's not success finished is what it is. If plan is empty, then do this. Otherwise, oh, somebody's making something that smells really good. Print line no plan. Alright, so now if we do this, we shouldn't get a plan because we don't have enough. Oh boy, I screwed something up. On null object. Oh. Let's try that. Okay, so start AI, eat. Alright, so we got no it should have said no plan, but anyway, why? Start AI. Oh, I didn't start it. Plan is null. Ah, I need to say if not plan, no plan. That's why. Boolean logic. Gotta love it. Yep, no plan. Okay, so now we can start adding our stuff back. So, like for example, if I come in here and I give it back some food, like we took out the near food, if we added one of these and just said is existing dot iterator dot, actually I think I can do this. It should succeed again. Yep, so this time it eats that one. But that's not really what we want. We want to we would like to start from near objects. And we would like to put in there all of the, so let's just say new list existing. Okay, we don't have enough things. Oh boy, it did not like that at all. Oh yeah, new array list. Okay, and then we have to give it the rest of the rules it can use to then to deal with that. So we have to fill out the rest of these. So we're gonna need food target, and we're gonna need closest types. Food target there. Doink, doink, doink. Uh-oh. I think this one we can just say null because we never wanted to pull a world value for that. We would if we should if we wanted an interim testability, but I'm just going to go straight for all of the rules working. But we will go ahead and set up this one. So we've got eat fully set up. Now we want to have keep up the good fight, Paul. I will do a rematch later to see stuff I missed. Okay, man. Thanks for joining. I guess you're leaving. Is that what I'm getting? The vibe I'm getting from that particular statement is that you're cutting out. Food. And so then we want to say requires new condition, new food target. Like this is the target of food we want to go to, and we want to make sure it's not equal to null, and just in case that its type name equals food, so that we're not. Now, built into the definition of food target is that we shouldn't be sticking stuff in that's not, but you might. So changes, action result, new near, new food target. So whatever the food target was, it's going to map that. Whatever this food target was that matched, it's going to map it directly to whatever we're near if the action succeeds. And so then we're going to do the does part. And so for this, we're just going to say we're not doing a real plan yet, so we don't have real actions yet. So we'll just do that. Okay, now we'll need to define our other. This should still compile. Shouldn't run, but it should still compile. Right? Yeah, so if I take this out, and I try to run it, it will basically it will run, but it won't find the plan. Uh-oh, didn't even run. Okay, so there is an error here. No such property rule for class. Oh, okay, yes. I don't need the rule part. No. All right, start AI, eat. Yep, no plan. That's what I expected because I haven't hooked up all the rules yet. Okay, so let's add the rule that finds the food. And so for that one, we're going to want to. Let me just grab this here. Okay, so it requires a object we haven't defined yet. It changes that to whatever we found. Closest types is going to return a list. I don't know how these rules worked, to be honest. And so then we're just gonna do that. Yeah, so it's gonna blow up because we haven't defined closest types. Blew up for some other reason too. No, closest type, that's where it's blowing up. Alright, so yeah, I don't know how this worked because closest types returns a collection. Oh, maybe it doesn't. I haven't copied it over yet, so could be I'm incorrect about that. So let's copy this over. Print line this, yes, sure. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, yeah, we're just returning the first one. This needs to be entity ID though. Okay, unable to resolve class action. Oh, okay. It's action rule, that's why. Alright, let's see if it had actions. Okay, so let's start AI and we'll eat. Uh-oh, blew up. It blowed up, sir. Type for entity, sure, it's type name. Okay. Eat. Alright. It looked around. It found one of the entities and it walked to it. Or it walked to it. So it looked around. I probably could show what we found. Looked around. Found blank. And then we could say IT get value new food target. And let's see what the plan looks like then. Start AI and eat. Okay, we looked around, we found, oh, that's not good. That is not good. Because I'd rather not do it this way. This should, in theory, work. But that's not really the right way. Yeah, so we looked around, we found 108, walked 108. So there's a bug in how this particular context that's passed to the action is wired. It should be the context that includes the changes that are applied, and it's not. So just something I have to be aware of. But yep, it looked around, we found that. So if I had the ability to send in actions, it would do what it was supposed to do. And then now we can start thinking about how we would want to debug this. Yeah, that's because I don't need action. I don't need the actions fully hooked up yet in order to debug plans. You know what I mean? As long as I can see the plan that was coming out, which we can. In fact, it would be interesting to have these, like if I click eat, to have it pop up a little window that lets me step through the planning phase, showing me things along the way, and then only once the plan is done would I be able to click, you know, maybe click execute and have it actually, have the object actually, have the mob, the NPC actually do those things. Hey, he's cute. He's like looking at his feet, but you know, dude, you got food right there. Yeah, these shadows are kind of screwed up. That's funny. Okay, so that is working. But what we want to do is something different. We still want to do that. But I think instead of yeah, gosh. What do we want to do? Let's just get something started. So I'm going to change eat. Oh, just like nearly took my head off with my foot. This thing with wired headphones. Okay, so instead of, let's say instead of try to eat, we'll make this plan to eat. Or eat planner. We'll have it return the planner instead of actually do the thing. So we will return planner. Okay, and then down here, instead of eat, we will what did I call it? Plan to eat, eat planner. And then we want to pop up a tool. Yeah, I don't believe I can easily add things here. So I kind of just like a pop-up. It could even have a draggable title if I wanted to be able to move it around. So let's make a class planner dialog extends container. Alright, and so then we can create a UI for this. and add child, new label, testing. Okay. Or we don't want to. Maybe we don't want to set this right away. Oh, we do want to have one. We just don't want to set it right away. And so then we can create a equals new planner dialog. So there's only ever one of them. And then when we say set planner, if this dot planner equals planner, just a good safety measure. This dot planner equals planner, reset children, protected void, oops, reset children, and this is where we clear the children and we'd add new children. And so then in here we want to say planner dialog set planner, and then planner GUI globals get instance show planner dialog. I think that works. Ooh. Okay, we've got to import. We don't have lemur imported. Import com.simsilica.lemur.star, another open source package. This one's used by a lot of people. Alright, so then you should be able to start the AI, and then if we eat, it should pop up a oopsie. No signature method. Okay, so it's like show pop-up or something. Come on. Oh, and I think it's like get. I can't just show pop-up directly. I have to get the pop-up state. That's what it is. So we got to say. Actually, we can move this into the planner dialog. So make us show get pop-up state, and then I think it's show pop-up. Show modal pop-up or show pop-up. Yeah, I can do either one. So show pop-up. Let's do show pop-up. That sounds funny. Okay, dot. Alright, so start AI and eat. Boink. Alright, we're still failing to do something correctly. No such property planner dialog for class planner dialog. Oh, that's right. It's this. This. Alright. Start AI, eat. Boink. Okay, it popped it up, but it didn't center it. There's a method for that too. Centering GUI. There it is. So we'll say oh, we're going to end up with a bunch of these in the yeah, so see, it popped it up. Now the problem is when we restart this, it's not going to remove it. See, and then if I start a new one, oh, it did remove it. Starting the UI, it removed it. Starting the AI, I mean, removed it. That is interesting. I can't explain how that happened, but what I really need is something like this down here to make sure there's only ever one of them, and that it's the current one. So we'll say this is like conditional. If it already has a binding, then oh, then we create the new one, right? If it doesn't have the binding, it would create a new one. Otherwise, we need to get rid of the current one. So actually, it's this that we want to do. If we have the variable already, then do this and blah, 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 blah. So that should, every time we restart, should clear the old one out. And then if we start we get a brand new one. Cool, 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 cool. And then I think we can do some stuff. Container children. So this one, probably I'm going to want style element ID. And so we can say new element ID window.title, I think. Start AI eat. Yep, okay, so we got that. That's all good. We could even add a drag label. So this is like a really quick lemur tutorial in a way, right? Because we're creating a really super quick AI. So we say, I think it's just mouse event control. I have to check. There's a drag handler already built in. Drag handler, and it is a default cursor listener. Okay, so cool, cool, cool. Cursor event listener. Cursor event control. And so we say cursor event control dot add controls to spatial, and we say label, and then we say new drag handler. I think. Nope. Got something wrong. No signature method, cursor event control. Yeah, I mean, so I may have. It's like add listeners to spatial. Okay, I got that wrong. Yeah, of course it is. All right. And so now, if we start the UI, we should be able to. Oh. Yeah. When you create one, you can actually. I think when you create one, you can actually say what you want it to drag. It's dragging the you know what? We'll just add it to the parent instead. But that's funny. Yeah, we were dragging the title around, no problem. Yeah, now we're dragging the window around. Okay. It's late, guys. What can I say? So I'm going to just try to get this basically fleshed out, and we'll call it done for today. So we want to, instead of this, we want to add children, this.children equals add child new container. So this will be the container where we add whatever stuff we want. Then we can add some buttons at the bottom. And for this one, I'm going to want to flip the spring grid layout around so that it's axis X by axis Y instead of axis Y by axis X. Just trust me on that. Okay, and then buttons, we add, I'm just going to add them real quick. New button, Step buttons.add child new button execute. Boink. Okay, so we should get little buttons at the bottom now. Start AI eat. Oops. Whoa, 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 whoa. It blowed up, sir. Body context with class body context. Uh-oh. Oh, we failed up here. That's why. Spring grid layout. Oh, yeah, wrong axis class, unfortunately. com.simsilica.lemur.axis. There's two different axis classes in my import space. Alright, so start AI. Didn't blow up. Eat. Alright. So yeah, so now we have a step button and an execute button, and we have a little place to show stuff in the middle, should we choose to. And so then for the plan, we actually want to say add click commands, and we will then say step, because in Groovy you can get away with this, I believe, and then execute. Somebody made a which JVM do you use? You mean like Oracle versus Adopt or whatever? Or version? Which do you mean, sir? Protected void step. Boink, 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 boink. Protected void execute. Boink, 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 boink. And we will print line step in here. Yeah, right now I think I'm using Oracle's version and JDK 118 or JDK 18. Yeah, 18 is how they say it. Java-version. Yes, it doesn't say brand here, but it's Java 18 at the moment. Okay, so we've got that, and this should work. Just hooking up basic UI right now. Start, eat, step, 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 step. Okay, yeah, we've got our buttons hooked up. They're not doing anything useful yet. Okay, and so then for this, we can say if planner step. So if it finishes, we probably need to keep track of the buttons then, don't we? Button. Okay, so that's fine. So we should be able to set it up, and then planner. Let me copy my code from up here. Alright, so let's see if we're basically hooked up. Blink. Step, 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 step. We finished. Yay. Yep, so it finished. Where does it say that it finished? Oh, I don't have that same. And what happens if we step again? Is it going to bluster? Yeah, okay. Yeah, so it needs to know that it is done. And stop doing things. Boolean. Done. So this set planner done equals false. And then we could say if done turn print line already done. So done equals true. Okay, let's start it up again. Which version of Java do you use? The one that's bundled with Mythruna is Java 18 when you download the game. Start AI, eat, wee. All right. Step, 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 step. I can keep stepping and it won't like blow up. Awesome. I can't execute yet, but that would be the thing that would execute the plan. And so that should only work if done. So if not done, or planner.plan, or not planner.plan, no plan to execute. Okay. So should be able to then say start the AI eat, execute should say no plan to execute, but if I step a bunch of times, okay, we're already done. Now if I say execute, it should let me execute. So we're starting to get hooked up. Now I need to start thinking about what I want in that center area, and I'll just like rough something in real quick in like the next 5-10 minutes to show what I want to do. I'm using the Java 21 data version. Oh, neat. Cool. Yeah, I'm like, when I upgrade Java, it's an event because I need to test everything and do performance benchmarking and things. So I see what got better and what didn't, and so on and so forth. Okay, so I think, I think what I want to do here is have a container for pending and a container for proposal. And I won't be able to fill out the container for pending yet. Or for proposal yet, because I don't think that the sorry, I'm typing and thinking at the same time, and both of those things are mutually exclusive. The planner doesn't let me know what its most recent proposal was, so I can't show any info about that, but I can set the UI up to support it. I think this is going to work. Start AI eat. Yeah, so we've got our little sections set up. And let's just, we don't want to necessarily reset children. We could reset pending and reset proposal. I guess they're both the same. Okay, so then every time we step, we want to reset the children. Yeah. And so, resetting the children. This is the perfect live stream to wrap up the week. Loosen up too. Nice. Yeah, and like for us in America or in the United States, we have a long weekend because a lot of us have Monday off for Martin Luther King Jr.'s birthday. Okay, so for this, I think I can hack into the planner to get the pending set. So I think, yeah, we'll get pending. Yeah, so we don't keep track of the current result, but we can at least keep track of what's pending. So pending.clear_children, planner.pending.each, proposal prop, because we've already got something that's called proposals, right? This should call it proposals. Nope, it's the current proposal. No, I'm wrong. Proposal info. Let's call them info. pending info, proposal info, pending info, and then down here, pending info, clear children, and then planner pending each prop, that's fine. Pending info dot add child, new label, prop dot to state something, to state string. Yep, it's going to be ugly, but it will prove my point, right? Okay, so this should be enough to make ugly. So let's start the AI. Let's eat. Okay. We've only got our little pending goal right now, which is it's not showing us what the goal is, but let's step. Okay, so now we've got one pending thing. Step. Yeah, so it's showing us the state of things so far. And if we step one more time, so because we've only got one chain in this particular rule set, we're not seeing multiple pending, we're only seeing the one pending, but it's showing us how it's building out the state as it goes. So at this particular point, at find food, walk to food, eat food, the planning context is still completely empty, but when it unwinds, okay, except for it's found closest types, which means that the next time it will unwind all that and we'll have finished. And so there's no more pending. We finished our plan. And this would be where in the final proposal, we would be able to show the plan, and then we'd be able to execute the plan. So I have like the basics to build out a little UI here, but we're kind of running out of time today. And I'm super hungry because I didn't eat lunch today. But anyway, this is sort of, you can kind of see what's going on down here. So I'm trying to like encapsulate some of this information into here, because as the decision tree gets more complicated, trying to track down what all's happening. Another thing I would like to do is, like we had the visual of, the graph as it was plotting its paths here. I would like to do something similar as an overlay for the GOAP rules, where it shows a view, kind of like this, where it shows kind of where we started from, goal, and then as it branches out to different things, it shows us, the different states that it's tried. And so we can kind of watch it walk the tree or walk the graph as it searches for a particular plan, because at each state, with this proposal and, the graph, then we'll be able to see, because the GOAP is really neat in that the NPCs will reason for themselves based on the rules. But it also, like, the big downside of these sorts of AI is that they're very unpredictable, in the sense that you get emergent behavior, and so if you see your NPC doing something really strange, it can be really, really hard to figure out why, unless you can open up sort of its brain and see the graph and how it's traversed and how it figured out to do the plan that it's doing and what plan it's executing and all that other stuff. So it'll be quintessential, and we've already built out stuff I can almost copy directly into Mythruna. So when we finish with this, I'll be able to replace the AI in Mythruna with at least, this much. So we're really on to something here, and I'm kind of getting excited because we get this done and we hook the town up to this. We have this graph viewable in-game, maybe as a debug feature if you're running single player. So like running single player, much like you can bring up the physics debug and all that other stuff, I think there'll probably be a debug mode where you might be able to bring this up. You open the console and you say, type a command in the console to bring it up for a particular entity. So probably there will be, because in the game is where it's going to be super hard. Like in this little prototype, I have all the debugging stuff I want. But if I'm in the game and I see some goblin running around in circles or something, and I want to know why, I'm going to need to debug him right away, and I don't want to have to stop and reset up my situation. So I like to build lots of debug tools right into the game. So anyway, our little Gayfin is just staring at his feet. He doesn't know how to eat his food. He's like, I don't really like pumpkins, especially little ones like this that haven't been fully grown. Anyway, he's cute. And I think that's where I'm going to end it. Thanks for those of you who joined tonight. Thank you. and I will see you guys next time. Please, if you're working on something creative, I hope you have a productive week. I hope to have a productive week. I'm going to be working on this all weekend and Monday, so hopefully we'll have something to show. And yeah, you guys have a great rest of the weekend too. Let's see if this is going to work. Come on. There we go. Yes. Thanks for watching. Like, comment, subscribe, and so on. And I'll see you guys next time. And keep an eye on the Discord and stuff. I'll be posting updates and stuff there, so that'll be cool. All right. Thanks, guys. See you next time.